Hi everyone, welcome back. So in the last video, we saw how to generate images from text using services like DALL-E from OpenAI. We used that to make an anime. And one of the problems we had was creating consistent images across various scenes. And in this video, we're going to learn how to fine-tune Stable Diffusion, which is another open source text-to-image generation model. And we'll see how we can use that to add characters to our model and also maybe even change, keep the styles consistent across various image generations. And before we do that, let's take a look at this image that was created using a simple prompt, a photorealistic, colorful portrait of Brad Pitt using Stable Diffusion. All right, here we go. To give a really high level overview of what Stable Diffusion is doing is it's a model that starts with a pure noise, and this model tries to predict the amount of noise that's in this image to get you to the final image that you want, which in this case is this portrait, right? So by predicting the noise and subtracting it from the input, it can generate this image, and you can do this progressively over multiple time steps with varying amounts of noise to get to the final result. And this final image is actually guided by the prompt that you put in, right? And so you can kind of, a really simplified version of this model, if you don't really go into all these details, is that you have an input, which is some image, some noisy image. You have an output, which is the noise. This is predicted by this model called UNet, and you also have a prompt that guides this image generation. And there are a lot of different models that are actually used, including text encoder. There's the autoencoder to go from latent to the actual image. There's also clip text encoder. So we're actually not going to go into all these details. What we're going to actually do is we're going to fine tune this stable diffusion model so that we can add new characters and new styles for our image generation. All right, so in today's video, we're going to fine-tune Stable Diffusion, and we're going to do that so that we can add new objects or styles to this model. And so you may ask, why is this useful? Well, if you ask this Stable Diffusion model to make a picture of, let's say, yourself, it actually doesn't know you, right? It may know some famous celebrities that it has already been trained on, but not specific persons or specific characters or even specific styles, right? And so what you can do is you can kind of train this Stable Diffusion or fine tune this model so that you can generate personalized images, like generating a personalized birthday card or in a very specific style. And let's test this. So we'll begin by just using the Hugging Face to download open source models. So in my case, I'm running this notebook on my local computer that has a GPU. You can run this model directly on Google Colab, where you have access to GPUs. So this notebook should work, and I'll post this on the link below. We're going to load this specific model, and we're going to create a pipeline that allows you to kind of generate images using a prompt. And as you can see here, Hugging Face is really streamlined using open source models, so it only takes a few lines of code. Basically you need to define the model name, you create a pipeline, and then you just generate your image. This process is incredibly fast when you run it on a GPU. All right, so the model clearly knows the word Brad Pitt, and it's able to generate an image, right? And you can also use it to do things like, generate a birthday card with a picture of Brad Pitt. But what if you wanted to do this with your own image? By being able to teach your model a specific word or token, you can now start creating consistent character across various image generation. So let's get started on that. So the first part to get this is to load all the libraries. In particular, we're going to load the clip tokenizer and then the clip text model, and we're going to also, load the autoencoder. We're going to load the stable diffusion pipelines and also UNet that we talked about earlier, very briefly. And then we're going to load this particular model, actually not the stability AI one. All right, so in this particular video, I'm going to try to train this AI to create an image of myself. And so what I did was I saved a whole bunch of headshots on this folder, on this images folder, and I'm going to train this or fine tune this AI to recognize my face. All right, so in order for the model to recognize me, so an object rather than a specific style. A style could be, a watercolor painting, or it could be an oil painting. But in this case, we're trying to recognize and replicate my face, or the headshot. So what we're going to do is try to convert this word into what's called embeddings. And the embeddings, that's where all that information is contained, so that the model can be guided towards creating an image of me with different prompts, right? So here are some example of different prompts that we're going to later on use to generate different images. And so to create that, we start by creating essentially a data set. So data set basically takes in that images that we loaded earlier, and then preps it so that it's ready for so that it can be trained using the existing stable diffusion model that we loaded. And so the first thing we need to do is we need to add this token, which we define with these parentheses or brackets, is that we need to add this to the vocabulary of our text encoder, right? The text encoder is something, because all these machine learning models ultimately take numbers as input. So you have to convert text into a number, which is done using a tokenizer, and that's what I mean by adding it to the vocabulary of this model. And then once that's done, you need to in this particular case, you also need to give it a placeholder token, and that means that it's just a rough initial estimate of what you're trying to do. So in this case, I just put headshot because, we're training the model to recognize my face, right? And then what we're going to do is we're going to load 3 other models. So the text encoder model, like I said earlier, the variational autoencoder. So text encoder allows you to convert prompts to embeddings, and then the variational autoencoder allows you to basically generate images from these latents. We don't need to worry about that right now. And then UNet, which is the most important model here, that allows you to predict noise from a given image, and we're going to progressively subtract the noise and generate our image, right? So once that's all loaded, we can just confirm that, here's how we resize the text encoders to add our vocabulary. So you can teach it multiple words, not just one particular word. And we're going to freeze. So in this textual inversion, we're only training the embedding vector. So we're going to freeze a lot of the model parameters. We're going to create this training data set using the directory where I had saved all my images of my headshot. We're going to load up that training data. Remember I talked a little bit earlier about how you're progressively removing noise, and this noise scheduler adds various amounts of noise in various time steps for this stable diffusion process to work. So we'll initialize that. And then there are a couple of parameters that are important to do this training, like learning rate and what's the batch size and how many train steps. So we're going to define all those hyperparameters here. And then after doing that, this is just the function that the training process, and a lot of the stuff that I'm showing you here comes from a stable diffusion deep dive course from Fast AI. So I encourage you to check that out. There you go really deep into how to really tweak the embeddings, how to look at the images in the latent space, all that stuff. But here I'm just trying to show you how to add your image or your picture to the stable diffusion model, so you can start generating interesting images with your object, your style, right? And then this training process, I already ran this earlier. I ran it over 4,000 steps. I'm not going to do that again, but all the learned parameters or that embeddings for that particular token is stored in this folder. We can actually take a look at what that looks like. All right, essentially after the training is completed, it generated these learned embeddings.binary file, and we can load that and we can see what that looks like. And what that is essentially you now have this token, and there's a long list of vector. We can see what that the length of that vector is. So it's a 768 long vector that represents this object, right? And this is what those numbers are, what are really going to guide this image to produce an image that looks like my face. And so this is kind of interesting how in a lot of machine learning models, especially ones where you are dealing with text, the text has meaning and it's represented in these embeddings. In this case, a 768 length vector, right? And then now that we have that, what we can do is we can now create a stable diffusion pipeline, and then use that embeddings. Using that embeddings, now we can do things like, we can say a colorful oil painting of portrait of, my headshot, right? So if I do that, there you go. It generates an image that looks pretty close. I feel like it's making me look a little bit older. I could probably try and say of young, see if it does anything. Oh, that's pretty funny. But as you can see, what that text embedding, by just training on that word or that embedding, somehow it's able to guide this model to produce an image that has a picture of something that looks like me. And in fact, this to fine-tune this model, I didn't use very many images. If you go back up here, I only used about 15 or 16 images, and I'm sure if we were to probably provide a lot more images, this model would be a lot more accurate. And so now you can do other things like, let's give this a try. A photo of me hiking. All right, not bad. You can see the image is a little bit messed up. I'm also using an older model. I think there are newer versions of the stable diffusion model, but this is how you can do other things like create a professional photo of someone. There's a lot of services out there that take pictures of your face and just using your iPhone and then generate a really professional looking image. But hopefully with this quick demo, you got to see how you can fine-tune stable diffusion using this particular thing called textual inversion, where we just teach the model what this word means and try to use that word to guide the model to produce the image that you want. So hopefully you found that video useful, and feel free to give this a try using the Colab notebook that I posted below. And as usual, if you liked today's video, please give a thumbs up and please subscribe to our channel. Thanks.